Thank you for joining this lesson. We're going to discuss transformations. Number 18, the points P, 15, Q22, R11, and S42 are the vertices of a quadrilateral PQRS. On the grid provided, draw the quadrilateral PQRS. So we're going to plot PQRS, whereby P is 15. So 15, this is going to be P. Then we have a Q, 22. So 22 is going to be our Q. This is Q. Then we have a 11. 11 is going to be our R. Let's coordinate 11. Then we go to coordinate 42. 42, so that we may get our coordinate S. Then now when we join the coordinates, we're going to get the triangle. Not the triangle, but the quadrilateral. PQ, according to that order, PQ. So from P we should go to Q. Then QR. Then RS. RS. Then now we can enclose the quadrilateral. This is PQRS, and as we can see, it's a quadrilateral, a four-sided figure. So that is how it will look like, and we have plotted it. In the next, on the same grid, draw PQRS prime, the image of PQRS, and a rotation of positive quarter turn about the origin. When we talk about positive quarter turn, it means a turn of 90 degrees, and the word positive means anti-clockwise. So when you see the word positive, it means anti-clockwise turn. Therefore, the rotation is anti-clockwise, and it's about the origin, anti-clockwise. That means we should be joining every point to the origin. So I'll begin with any point. So from R to the origin, and also from Q to the origin, because they are on the same line. Then I extend a little bit so that I may make a measurement of the angle of rotation, which is 90, and in the anti-clockwise direction. If it was clockwise, we could have measured from the center of rotation in the clockwise direction, but now we should go in the anti-clockwise direction. Therefore, I will stand here and I measure an angle of 90. I measure an angle of 90 degrees. 90 degrees. So this is 90. And following this line, we have gone to the anti-clockwise direction. Therefore, I'm going to use a dotted line for that matter to connect with the 90 degrees mark. Then now mine will be transferring now the distance, because I've already turned 90 degrees. This is 90 degrees. I would now transfer this distance from the center to R, an equal distance along this line, and R prime is going to lie here. So this is R prime. Then 1, 2. So 2 units, I will be able to get to Q prime. So this is going to be Q prime. So we have R prime and Q prime. We can proceed and do a rotation for the other 2 points. That is going to be point P. So from P, I join to the center of rotation. To the center of rotation. Then now I proceed this side. Then I measure my 90 along this line connecting P and center. I'm going to measure 90 degrees. 90 degrees. So I'll stand here and I connect the 90 degrees measurement. Yes, that is the line showing 90 degrees from P to the center, then 90 degrees in the anti-clockwise direction. Mine will be to stand at the center. I pick the distance to P. Then along this line now, using the same radius now, I mark, and I'm realizing that the same distance will take me to this point. So that means my P prime is this point. That is P prime. And finally, I got S. So I rotate S. I connect S to the center first, to the center of rotation. I'm using dotted so that the complete lines can be used for the images and objects. When I connect like that, I now stand here. Through that line, I need to measure 90 degrees. Yeah, I need to measure 90 degrees. 90 degrees. So that is the point. I now produce my dotted line again from here. I produce my dotted line. Then again, I'm going to stand at the center, and I pick the distance from the center to where S is. Then I transfer that distance to somewhere along the line here. And that is the point that will become my S prime. So this is going to be S prime. Basically, to rotate is to connect a point to the center, and we measure the desired angle in the desired direction, 90 in the anti-clockwise direction. Then now that I have done so for all the points, now I can join them. PQ. So I join P and Q. Remember, we don't just join any points. We must follow the name of the quadrilateral. PQRS. So from Q now we go to R. Then S. Then S. Now I can join to complete the quadrilateral. So now this is the rotated quadrilateral, PQRS. Then we've also been told, after doing so, to state the coordinates. So P is going to be -5, +1. Q prime is going to be -2, 2. R prime is going to be -1, 1. Then finally S prime is going to be -2, +4. -2, 4. So those are the coordinates of the rotated triangle. Not triangle, but quadrilateral. The points P double prime, Q double prime, R double prime, and S double prime are the images of P, Q, R, S prime, and are a reflection in the line x-axis. In the x-axis on the same grid, draw the quadrilateral and state its coordinates. Therefore, we're going to reflect. Now it's a reflection. It's a reflection along line x-axis, which is here. This is the x-axis, or the line y equals to 0. Now we're going to reflect here, and to reflect, we just join P to the mirror line, then we move an equal distance to the other side. So we're going to find ourselves here. That will be our P double prime. Then for Q, we join Q to the mirror line. Then now we move an equal distance, because we have 2 units now, we go 2 units on the other side. That is going to be our Q double prime. Then we drop our R prime from here to here. Then an equal distance to the other side, we will find ourselves here, because this is the mirror line. I'm just bringing points there and an equal distance on the other side. So this being R prime, now this will become R double prime. R double prime. And finally we got S. So we drop S to the mirror line and we move an equal distance to the other side. That means we will find ourselves here. This is going to be our S double prime. Let me try to use a different ink. So now P, Q, R, S. So P to Q, P to Q. Then we have to R, then to S, P, Q, R, S. Then now I can connect here. So this is now the third triangle, which is the image of PQRS prime. It becomes this one. So this is the quadrilateral. And now to state the coordinates, then P double prime has become -5, -1. Q double prime has become -2, -2. R double prime is -1, -1. And finally S double prime, which is here, is -2, -4. -2, -4. Finally, we got another question here, which says quadrilateral P double prime, Q double prime, R double prime, S double prime is the image of PQRS under a certain reflection. So now we are told that this image can be related by the object by a certain reflection. The question is specific that it's a reflection. On your graph, draw the mirror line for the reflection and state its equation. Which mirror line is able to map PQRS onto the double image, the second image? So for us to know the transformation, the transformation has already been specified. So we can talk about describing the transformation, which is a reflection. We should connect, if it is S, with S prime. Just giving examples of coordinates. If it is S and S prime, S and S prime, then after connecting now, I bisect perpendicularly that line. S prime now should be bisected. So I will stand here, I make an arc, then now using the same radius on the other side, I make an arc and I make an arc. Then now I can connect to come up with that perpendicular bisector. Therefore I got this point and the other point there. This point, sorry, and this one. Yes. So I connect. Now that perpendicular bisector should give us the mirror line, LL, according to the question. Now if that is the mirror line, or we can confirm the mirror line using another point, a point like a P and P prime. So P and P prime, when I connect the two, then I bisect. I should also get the mirror line. Therefore I can bisect P prime. I can produce an arc there and another arc here. Yeah. Then I stand at this other point with the same radius. I make an arc there. And I stand here again, I make an arc there. Therefore now, when I connect the two arcs, I'm going to pass through the same line. Therefore, the same line is confirmed. The same bisector is confirmed to be the mirror line. So that is the mirror line. Now we can get the equation of the mirror line according to the question, and this is the line y equals to negative x, because if we try to pick some values of y and x along the line, you will discover if it is, for example, we have a negative 1 1, negative 1 1, negative 2 2, negative 3 3, and such. So the equation of the mirror line is y equals to negative x. Thank you for following. Subscribe and share.